Hi, thank you so much for having me here. I'm really excited to be included in this program. So I'll be presenting what was my job market paper, the personalization paradox, welfare effects of personalized recommendations, two-sided digital markets. It's a really long title. But there's some important keywords here. So we'll go through what are recommendation systems, what does it mean to personalize them, and what kind of two-sided digital markets are we talking about? So recommendation systems determine which products appear when you search in e-commerce settings and the order that they appear in. To personalize the recommendation system means that the algorithm is taking into account information about the consumer to curate which products appear in the order. That information can be quite personal, like purchase history, information, past clicks. It can also be a little less personal, like what country is the person searching from? If it's hotels, it might be what time of day are they searching? And for two-sided digital markets, what I have in mind is one where we have consumers like us, sellers. In the setting for this paper, I'm using data from Expedia. So the sellers are going to be hotels selling room nights. Then we have the intermediary or the platform, and in this case, it's Expedia. Each of these groups get to make a few decisions. So the platform chooses its design. I don't know if you can see all the way down here. So one of those is the recommendation system. It's also the revenue model, which Juan was just talking about. The sellers can set prices. So in Expedia's case, we have hotels who are setting the prices for their room nights when they're participating on Expedia. And then consumers like us make our search and purchase decisions, and we can think of those as clicks and purchases. Now, as a preview of the paper, the color coding here is a little important. So we have in orange the recommendation system. What we're going to do is we're going to think about different potential recommendation systems Expedia could use. And with that, we're then going to endogenize the prices the sellers are setting in the search and purchase decisions the consumers are making. We don't want this. Yes.
What do you mean by feature visibility?
Oh, so feature visibility is going to be like, are the fees, do they show up, like is the price the final price when you're searching, when it's on the landing page versus you have to click to learn about taxes and fees? There can be other product features where you have to click to go to the product's actual page. That's included in the model, but I'm not letting the platform endogenously choose what's visible. Okay, so zooming out from just Expedia, how common do we have this setting where a platform is choosing the recommendation system, but third-party sellers are setting prices? In accommodation, in addition to Expedia, we have Booking and Airbnb. Together, they did almost $500 billion in revenue and transactions through those platforms in 2022. We also have restaurants and groceries. So for example, on Instacart is not setting prices. Grocery stores and restaurants set prices. We have it for event tickets. Then even for Amazon, about 60% of the units sold are from third parties who have the ability to set prices if they want to. Okay, so we've been through recommendation systems, personalizing the recommendation systems in two-sided platforms. So that brings us to the research question, which is what are the welfare effects of personalized recommendation systems when the sellers are able to adjust their prices, and also when consumers are able to update their beliefs about what the algorithm recommendation system is doing. Now, from the literature, we already have some research that says that personalization can be great. There's this efficiency gain. So if we personalize, consumers can match to products that better fit their tastes. Maybe they're able to find a match without as much search effort, and that can increase consumer welfare. A lot of this research might focus on small A/B tests where there's not necessarily an incentive for the seller to change prices if we're just experimenting on a small set of consumers. We'll focus on engagement goods where there's not a relevant price or generally hold the seller's strategy fixed. I think one of the main things I want to focus on is what happens to prices. So we're going to go through three forces that might say that prices will change as a function of the recommendation system. So the first is the main one I want to walk through. So imagine we have this fictional hotel called the Elvis Hotel. It's a niche good. It's Elvis themed. We have two types of consumers. Type 1 is our typical online shopper. Type 2 is a huge Elvis fan and has a high willingness to pay for Elvis themed goods. Okay, now the platform's going to mediate when people are shopping which products they see. So if we have a default recommendation system that's not personalized, what might the distribution of people who see the Elvis Hotel look like? It will look like the population distribution. So we have many common or typical online shoppers and only the occasional Elvis fan. Facing demand from that set of consumers, the hotel will set prices, and let's say it's $120. Now let's think about what happens when we personalize. Well, if the recommendation system is any good, it might look something like this. We're matching the Elvis type consumer to the Elvis hotel. This is part of that efficiency gain we see where we're matching the people who might want the good more to the product. However, now when the hotel's setting the price, it's facing demand from a different set of consumers, the set that's better matched their product and has a higher willingness to pay. So they might have an incentive to increase their price. So this is the main trade-off I think about in this paper, where we have the efficiency gain, we have better matches, but also we have higher prices. And so now that makes it unclear whether this is going to improve welfare or not improve welfare. The other thing worth pointing out here is that this is a little different than price discrimination. So in price discrimination, you might worry that either the hotel or the platform knows which consumer is which type and charge them different prices. In this setting, it's the market price that's changing. So everyone's facing the same set of prices. It's just changing rapidly. Okay. Is there a question?
Clarification. So in your second areas, we just better matching results, higher prices, or also better matches with lower prices.
Okay, so this is like a cartoon that oversimplifies. In the model, it could go either way. So you can imagine that instead of the important feature being Elvis themed, it's price, and you end up with a recommendation system that's like really tuned to price. It doesn't necessarily need to go that way. Okay, yeah.
If we move away from this world into one where price is also personalized, could you predict the effect on welfare by that move alone?
I would have to think about it. I'm not sure. Yeah.
You allow for obviously multiple sellers to target the same consumers.
Yes.
Personalized information.
Yes.
So the guy in the middle who is getting a personalized information might be getting it also from other sellers.
Yes.
So in that sense, would there be intensified competition for that guy?
Yes. Let me get 2 slides down and we'll get to that. Okay, so this is one of the main forces, but there are 2 others that could also change how prices competition is impacted by recommendation systems. The first is that the recommendation system itself is usually a function of price. So a firm can lower its price to be promoted in the rankings. These are the default rankings, right? When you're higher in the rankings, we have plenty of research that shows being higher up, all else equal, that's great for you. You get more impressions, you get more clicks. So you might get more business in terms of quantity if you lower your price in the setting. That also means that whatever the recommendation system is already impacting the equilibrium prices. And so if you change to a recommendation system that's more or less sensitive to price, that's going to change the price competition in the market, right? Now, this one, when we personalize, isn't as clear because we don't know if we're moving to the right or moving to the left in this figure. So it's a careful question. The other thing, and this goes to your point, is that we have differentiated goods, but there's some goods might be closer substitutes than others. So one of the other forces is co-ranking close substitutes. So here I've added another Elvis themed hotel. You can imagine one version of personalization is gonna put these hotels far apart from each other, where another might put them quite close to each other, and that's gonna change the level of price competition as well. Yeah.
So how do you distinguish between personalization in rankings versus filtering? Like if the consumer actively filter, is that still a form of personalization?
No, so I'm gonna abstract from filtering. I can talk to you a little bit more about that. In my data, it doesn't look like people really filtered that much, but I can't say more about that specific. Okay.
So often do the recommendation system consider about the equilibrium price?
No, they don't. So a lot of the ways that these things are deployed is through small A/B tests where the platform will randomize or like create some small amount of experimental data. And then they'll train a new algorithm on that. Then they'll deploy that new algorithm in a small A/B test on like a very small percent of consumers. And if that gets lift or if that gets more purchases, for example, than the default, then they deploy it, and they're repeating this hundreds and hundreds of times and testing a bunch of features. But they might miss that there's gonna be an equilibrium price effect, and that's because when you're running the A/B test, only a very small percent of the market is getting personalized recommendations. That's not gonna change the overall demand that the hotels in this case are facing. So they're not gonna adjust their prices until it's. Okay, so we already went through the research question. I already previewed. I'll use data from Expedia. They hosted a competition to personalize their recommendation system. Includes clickstream data. A number of papers use this. Geo has a few papers that use these data. I get to see what people clicked, what they saw on the first page, up to 35 items, and what they purchased, along with a good amount of information about the consumers, the products. With that, we'll go quickly through what the paper does. So the first thing I'll do is I'll go through a number of reduced form results that help inform my model. With that, I'll show evidence that both search costs and consumer beliefs drive position effects. So consumer beliefs are consumers knowing that the algorithm has access to more product features than they're able to see on the landing page. And that belief is going to drive some of the advantage we see that products rank higher. Yeah. From there, I'm going to develop a structural model with 3 parts. There will be a demand model, which is an optimal sequential search model, a platform recommendations model. This is a machine learning task where I reverse engineer Expedia's default recommendation system at the time. And then a hotel pricing model. From there, I'll have parameter estimates that I can use to evaluate different counterfactuals with different recommendation systems. What I'm gonna do is I'm gonna create a series of recommendation systems that are based on the winning entry in this competition. One of the nice things about this competition was to collect your prize money, you had to give this like very detailed talk about what you did. So instead of trying to be a computer scientist from scratch, I mostly just follow what the winning entry did. I'm gonna train 4 of them, and they're gonna have increasing levels of personalization, where I give it access to more and more private info or personal information about the consumers. These data use these are gonna be based off of data from an A/B test or a small experiment Expedia ran where they randomize order winners. Okay, so I'll have a set of recommendation systems. I'll have parameter estimates from my demand and supply side models. From there, I'll evaluate the counterfactuals, and I'll do it 2 ways. One, I'm gonna hold prices fixed. The other, I'm gonna let the sellers update their prices. Question?
So when you think about sort of welfare effects here, it seems like a lot of this is contingent on specifically like what the platform is doing to generate recommendations based on the data. I guess maybe you'll be able to do this later, but like if you're able to sort of speak to whether what they're doing feels like something that probably everyone is doing, and therefore this is very generalizable, or is what they're doing very Expedia specific and very competitive?
Yeah, so I think at the time what they were doing was like generally what most of these platforms were doing, where like the winning, like the 5 top entries were all using the same algorithm. It's called Lambda Mart. It was the basis for bidding. Now there are like better neural net versions since like this data came out. But the A/B test in structure and stuff was like, I think, pretty common.
So like
The other
it's
thing
not
that's-
structural in terms of like platform algorithms trying to maximize the big into your menu, right? So
Yeah.
you just gave us a slide on how you potentially increase revenues by not showing someone a good alternative.
Yeah.
So it'd sort of be good to know what the actual underlying, even like if it's just a guess about what the actual underlying structural logic of like structural
Yeah.
equation is like. So we have some sense for what we should generalize.
Yeah, so what I'll say is like for this paper and the data at the time, I think this is pretty close to the industry standard. And part of why I'm saying that is Expedia was hosting the competition and they got to state like, this is our objective function. And so I'm trying to match that with the recommendation systems. I do know today, like, this is just like an area of the industry that has grown quite a bit. And now there's gonna be like an ensemble of models where like one chooses which set of products appear, another chooses how to order them, then another after that is gonna be like, what are the portfolio effects? And like, that's closer to the cutting edge. That's not something I'm able to do with these data. Okay, so that's a setup for the paper. To preview the results, I'm gonna find that both search costs and consumer beliefs drive position effects. The way I show this is in addition to the reduced form evidence, I'm gonna re-estimate my demand model with and without the belief assumption. I'm gonna show that it fits better out of the data when I include the consumer beliefs. Without price adjustments, I have results pretty consistent with literature, so consumer surplus would go up by about $1 billion for that year. However, once we let the sellers update prices, it results in a welfare loss. What I see is consistent with a market becoming more segmented and less competitive. So we have a decrease in quantity, an increase in prices, about a 5% increase in profits for the hotels. The platform, had they gone through all this effort, ends up in kind of no different of a spot because they get a percent cut of revenue, prices gone up, quantity's gone down, and they end up with about the same amount of revenue at the end. And then consumers end up having a decrease in surplus. They lose about $2 billion in consumer surplus. It's about 5% of total booking revenue for that year. They're gonna lose almost twice as much as the sellers are gaining, so this is a loss in consumer surplus. This is also a total surplus or a total welfare. Okay, so I think this all highlights a potentially overlooked concern in e-commerce platform research and regulation, which is that better recommendation systems may end up reducing competition in market. Okay, so this contributes to a bunch of literature. A bunch of people are in the room who've done a bunch of this great literature. I'd say one of the main, on the econ side, contributions is that I'm endogenizing the seller pricing decisions as a function of the recommendation system. Okay, so a preview of the rest of the talk. I'll talk briefly about the data and setting and go through some of the reduced form evidence about position effects. On the structural model, since I think there are a lot of amazing search people in the audience, I'll spend a little more time on demand and we'll briefly go through the platform model, supply side model, and we'll jump to counterfactuals and some of the next steps from favorite poet.
I'm just wondering if, like, in the hotel setting, I think with a lot of Expedia, they sometimes allocate X number of hotel rooms for Expedia or sites. That the platform or the hotel, if they have sort of an outside option for the platform, also instead adjust supply of hotels that they allocate to these platforms and potentially offset the increases in prices that
Yeah, so to jump ahead, the supply side model is going to have soft capacity constraints, which capture some of this. I'll re-estimate the model where like I can't really say anything about like platform participation, but what I can do is I can remove the capacity constraints and see how much that changes the welfare effects and those results. Okay. So the data and setting, again, Expedia hosted this competition it was called the Personalized Expedia Hotel Searches competition, released an amazing data set that's publicly available still today on Kaggle. It includes impressions, clicks, and purchases. It also includes this experimental data where they randomized the order that hotels appeared. Okay, this is actually a picture of booking, but it looks more like Expedia did at the time. So in one of our typical online settings, we have what's called the landing page. This is going to give us an ordered set of products with a small set of the product features. You can click, and once you get to the profile page, you get to learn much more about products. Also, often in these settings, you have like these additional taxes, and sometimes like resort fees are added on. So the price that appears on the landing page is not the final price you end up paying. Okay, so now we're going to go through 3 reduced form findings that help inform the setup of the model. So the first is going to be that slot. So this is position on the page, impacts demand, even when the recommendations are random. So here we have 2 versions, the same plot. On your left, we have data according to the default rankings. On the right, this is data according to the random rankings. The horizontal axis is position, so this is the top of the page. This is the bottom of the page. We're plotting the concentration, so the percent of bookings and clicks. On the left, we see obvious, I don't want to say position effects, but most of the economic activity is at the top of the page. Now, if we think about our standard demand model with full information, like what do you expect to see this? It's possible, because if the recommendation system is good, just the better products are higher up on the page. However, if that was the case, what would we expect on this side? We would expect a uniform distribution because these products are no different from each other, right? The order is random. But instead, we still see most of the clicks, most of the bookings happen towards the top of the page. So that means that we have a setting here where there's not full information. We have evidence of position effects. Could be more than just the visible features. It could be search costs or consumer beliefs about the recommendation system. The next is going to be that slot is correlated with hidden product features. So on Expedia at this time, if you search for a hotel on the landing page, it will tell you the neighborhood, but it wouldn't actually tell you where the hotel was until you clicked. So imagine you're trying to go on vacation at the beach. The landing page, you can see this hotel is near the beach. You have to click to actually learn that this hotel is on the beach versus like 3 blocks away from the beach. And like, that's a quality difference. The data includes 2 scores, and we see that both of these are quite correlated with position on the page. Okay, so this means that we can't necessarily rule out beliefs because the website's designed in a way, and we have a relationship between position and hidden product features, where rational expectations, for example, about the algorithm might justify the pattern. Okay, the other thing is that this means that if we're just using the A/B test data, the randomized data, we might still have an issue. Why? Because consumers don't know they're part of an experiment. These product features are hidden, so they might still be clicking according to their beliefs about what the recommendation system is doing. Which means that I need to set up a structural demand model that includes both consumer beliefs and search costs. Okay, the last we can skip this one. This one's like the least surprising of all of them, which is just position on the page depends on price. So if the hotel changes their price, that will change where they appear in the rankings. But that also means that counterfactual policies that change the recommendation system would also change the prices hotels want to set. So that means I need a supply side model. So to take stock here, there are kind of 2 general equilibrium effects I'm trying to address. One is about the consumer beliefs, or if you change the recommendation system, in the short run, consumers might behave one way because they don't know that there's a new recommendation system, but in the long run, they might update their beliefs to the new, better recommendation system. And the other is that the sellers are going to have an incentive to change their prices once the whole market has the new model. Okay, so that brings us to the structural model. So I'm going to do a high level here, and then we're going to go deeper into the demand model. So the demand model is going to be an optimal sequential search model. One of the key features is that slot, so position on the page, impacts demand both by search costs and by beliefs. And by beliefs, I mean rational expectations. So people know the joint distribution of product rankings and product features. You're going to estimate it using maximum simulated likelihood. One of the keys here, or the tricks, is that I have this inner loop that solves for reservation utilities, which is required when some of the product features are hidden, right? Okay. From there, I then have this platform model. This is going to be a machine learning task. So what I do is I reverse engineer Expedia's recommendation system. I have tens of thousands of search results. This is, I used to have trouble explaining this, but now in the age of AI, like OpenAI is mad at DeepSeek for like entering all these prompts and maybe reverse engineering their model. Like that's basically what I do, right? So I have all of their results. I have a bunch of the information that's used to create the rankings. I just train a new model to mimic what theirs is doing. I need to combine these to get the elasticity of demand that sellers use, right? So like in the typical IO settings, we might model automobiles or yogurt. In those cases, we have downward sloping demand because people don't like high prices. In this case, if a seller changes price, that also changes where they might appear on the page. So I need to merge these 2 models together to get elasticity of demand. And that brings me to the supply side. So this is going to be a bit more standard in the setup. One exception is just the estimation is pretty standard. The interpretation is a little different than our typical setup. But like, let's use the cars example again. We usually think of the marginal cost as the cost of production. In this case, the hotels are doing some dynamic pricing. So if I sell my hotel on Expedia today, that means I can't sell it on booking and it's not available tomorrow and demand might be different and I want to sell the room. And so the interpretation is that this is an opportunity cost. It include two key features for hotels, which is economies of scale and capacity constraints. So a very low occupancy, I might have decreasing marginal costs because I can add another room night and I don't need to change staffing or anything like that. Then as you get to the capacity constraint, you have to pay overtime. There are these things that are really gonna make the cost shoot up. And then I'm gonna use VLP type instruments, so this is gonna be the mean and variance of the features of rival. Question?
Sorry, my question earlier. Given you got the interval solving for reservation utilities, I presume you're using the Weisman type search model. So Weisman type search model, this is of course, it might be more general in your paper, so you know my answer is fine. But it presumes I can open boxes in any order depending on my reservation utilities.
Yeah.
In online retail, items are listed, the order in which items are listed is determined, say, by the recommendation element.
Yeah.
So can I really search any order?
Yeah.
You know, I've looked at data and I don't find people that click on item 55 and then go back and click on it.
Yeah, so in these data I'm using the naturally ordered data, and like over 90% of the observations, people only click one thing even when they're making a purchase, so like the order ends up not being that relevant. Unfortunately, with these data, it didn't report the order, so I have like another model where it's just assumed that they're searching in order of likelihood of a click, but it's not always the order of position. But I mean, there is something to be said, like in the online settings, like it usually makes sense to search in the order that things appear, right? Like it's lower search costs higher up on the page, and also the items are more promising if the algorithm's good.
It's really apparent when you look at scrolling data, you just don't have much option.
Yeah.
Okay. Just curious.
Okay. Okay, so going into the details of the demand model. So we have indirect utility for a room night. So this is per night utility. It's split into visible and hidden utility. The deltas are going to come from observables. So these are features that I observe and the consumers could observe. There's going to be a set of, here the delta with the superscript V is for the visible features. So this is going to be like star rating of the hotel. The delta with the H is going to be these location desirabilities and like any hidden fees. The epsilons are the match quality terms. So there's both a visible and a hidden one. In the model, this ends up being data driven of how much of this epsilon term people know ahead of time versus how much they learn from search. To learn the hidden delta and the hidden epsilon, the consumers need to pay some search costs. And that search cost is going to be a function of position on the page. One thing worth noting here is that this is the per night utility. But in the data, I have people staying for 1, 2, 3, or 4 nights. And so the final utility is going to be the length of the stay times the per night utility. Then we subtract out the search costs from any of the clicks, any of their searches. This ends up being important for identification later. Okay, so the overall demand is going to depend on all of these parameters. It also depends on consumers' beliefs about the hidden portion utility. Olivia?
Does this also imply that search costs should scale with like the size of the purchase, like specific, even though the information is?
No, that's a great question. So this is exactly the source of identification. The idea is that I have variation in the returns to search because some consumers are only staying for 1 night and others are staying for 4 nights. But presumably when they're sitting there at their computer or on their phone scrolling, they're facing the same set of search costs. So what I have is settings where we have comparable search costs with variation in the returns to search. And that's what helps me separately identify the search cost terms from the.
If there's a greater degree of potential for longer stays, but how do you substitute it?
So I don't have. So that would be justified by this, right? So if the returns to search are higher, but the search cost is the same, people are gonna incur more search costs on the search.
Oh, sorry, I mean like per product.
Per product, okay. So what I have is like a revealed click. I don't have dwell time information. That would be a really nice thing to include in the model. Okay. You can skip the platform. Assign parts. The paper is about personalization. My general preference is to keep demand models as simple as possible to answer the research question. But this paper is about personalization. And if I had a very simple model, people wouldn't be very different from each other. And I'd be like, oh, personalization doesn't really matter. Unfortunately, in this case, I have about 60 parameters in the model. So we have a set of visible features. This includes the star rating, which is a category of hotel. So 1 star is like motel, 5-star Ritz-Carlton. We have brand versus non-brand indicators. So that's interactive with star rating. We have a few things like property review score. This enters the model flexibly for spline, some market time effects, and then some consumer segments. So this is important for identification, where for the hotel market, you might think that there are times where the quality or the desirability and the price move together. So like, I went to school at Michigan, football games and graduations, all the hotels are like 4 times the price, but they're also more desirable. But it's not that like one hotel is getting this shock and the other isn't. And so I include these market time effects that are going to shift the desirability of the hotels, but that might be correlated with price. You can have random coefficients on the inside option, the star ratings, the price and the search costs, and also correlated random coefficients on price and search costs. Okay, so in terms of price and search costs. So in terms of estimation, I'm going to use the sequential search rules from Weitzman with the logit smoothing approach. There are 2 sample selection issues that I address using. One is adjusting the likelihoods, the other is using sample weights. And then I'm going to test the structural assumption of position effects, and this is just I re-estimate the model a second time without position effects being included in forming consumer beliefs. And I show that I fit the data much better when we include beliefs. The nice thing about this is the underlying number of parameters are the same. It's just the structure is different, and so I can compare the in and out of sample likelihoods. So some of the last things on the demand model, we've gone through the setup. To estimate the likelihoods, I need this other object, the reservation utility. So here we have per night utility. The superscript is just for like the draw index when I'm doing a simulation. The search costs, I didn't mention before, it enters flexibly. So this is just notation for a spline. So I'm not making any parametric assumptions on how position on the page impacts demand. It's just flexibly estimated. Then for the reservation utility, we have these 2 elements. This is the expectation of utility from the hidden product features. And then this is going to be this portion that solves an implicit function. It's going to be based on a set of state variables, and this is something I need to solve inside the estimation loop. I do this on a grid, then fit a spline to the grid, then I have this nice interpolation object. Now, I think it might be helpful, especially because we have so many search people here, to go under the hood of the search model just a tiny bit more. What I want to talk about is how price impacts demand. So in the full information setting, price impacts demand because people have a disutility of price. In this setting, we have that, right? It impacts demand directly through the transaction costs. But we also have some other mechanisms. So for example, it impacts demand indirectly through search costs because the recommendation system is a function of price. If you change the price, it changes the position, that changes the search costs. It also does it through the reservation utilities, through the expected price, also indirectly because there might be some joint distribution between the visible price and the hidden product features. And there's also the joint distribution we have to worry about between position on the page and the hidden product features and position on the page, depends on price. So all these go together that impact our elasticity of demand with regards to price, and all those are elements. Okay. So the last thing on the demand model is to talk about identification. I already previewed this a little bit. So the parameters, it's maximum likelihood. So in a sense, everything identifies everything, but some sources of variation are a little more helpful, right? So here we have the set of optimal sequential search rules. These help jointly identify the utility and search cost parameters. There's also some helpful variation in the data. So like I said before, the length of stay gives me a nice setup where there's variation in the returns to search, but the same set of search cost people base. This helps me separately identify utility from search costs. We have the diversion. So this is like, there's a bunch of kind of randomness, or people are facing different assortments of different products in different positions. And so this helps me identify parameters as well. Then we also have displacement of these ads for opaque offers, just sometimes appear and they shift down products. So they end up in a different position that should impact search costs, but not the expectation. Okay. So this is the fit, there's room for improvement. The model's on the joint likelihood, so it's not actually, these aren't moments that are targeted, but this is just showing summary statistics, so. The version of the model right now is still slightly underestimating or under capturing the position effect, so I'm a little lower in terms of number of purchases and clicks by position. But there's a newer version of the model that I feel helps here, all these things have gotten a lot closer. Okay. So in the last few minutes, I'm going to go through the platform model quickly. So I previewed this already where this is a model of a model approach. Where imagine that the platform is ordering things by some score. So a relevance score, part of it is deterministic and part of it is random. The deterministic part is some function of observables, but I don't know what it is. And so what I'm going to do is I'm going to use this algorithm called lambda mark to just try and reverse it. Instead of like going too much into the details, I think I can show you the out of sample fit. So here we have a plot where on the horizontal axis, we have the predicted position, and on the vertical axis, we have the actual position. This is out of sample. So if it were perfect, what would I expect? We'd expect a very dark diagonal line. This is pretty close. So about 72, 73% of the time, if you take any two items, this will correctly rank one over the other the same way the algorithm does. And if you can tell, it's a little bright. It does much better near the top of the page, and that's where most of the economic activity is. There's this additional step where I need to run a logit. So when you run this algorithm, there's no scale. You just say like, give me a score between 1 and 10, or scores between 1 and 10. But I need to scale it to the error term, figure out how deterministic it is. So I run a logit at each spot to figure out the likelihood of ranking with regards to that score. And I need that to be able to get these elasticities or the actual relation to the rank. Yeah, Carl.
Sorry if I missed it. Does the consumer know the ranking algorithm?
The consumer knows the joint distribution of hidden product features in the rank. So it doesn't mean they know.
Do they know the distribution of attributes in position K+1 condition on what they observed in?
No, so there are not learning spillovers, so you could think of a version.
In the absence of learning, if I'm changing ratings in the counterfactual, then my beliefs about what occurs next should change. So, for example, if I order items by price, then I know that the next thing I look at has to have a price either less than or equal to the one I just ordered.
Yeah, so that's right. So in Athey and Ellison have this in their paper where people Bayesian update as they learn something that's hidden. I don't have that kind of learning in this.
Yeah. So what do you think the implications are for sort of counterfactuals? Because hotels then, yeah, I'm just curious your thoughts.
Yeah, so I think that has more bite when we don't have the, can I come back to that after the talk? Because I only have 3 minutes left to get through the counterfactuals. Yeah. Okay. So the supply side, pretty standard. I use BLP type instruments. The firms are going to maximize expected revenue. The marginal cost does depend on quantity, and so I need this additional IB just for demand. Sorry, there are a lot of buttons here. Okay. Let's get this. I'm happy to talk about that more. So now assume that the supply side made sense to you. Now I have parameter estimates for the demand and the supply side, and I can evaluate different recommendation systems. This is just saying that I follow the rules, the competition, and the methods that the winning entry use. And I'm going to train 4 increasingly personal ones. I'm going to increase the level of personalization by giving it access to more product features. So or more characteristics. The least personalized one is only trained on product features. The next one adds information that consumers actively volunteer. Like you can say, I'm searching with children. This is the information they enter in with the search. The next includes information like what country are they searching from. And the last has the purchase history information. For the counterfactuals, just gonna jump. Okay, so for the counterfactuals, this is the one where we've updated everything. So you can first look at consumer surplus. So in the blue line, we have consumer surplus. This is going from baseline to most personalized. we see that consumer surplus goes down as we increase the level of personalization. The orange line is the utility of the item they're choosing. This includes the pricing effects. So we see that the utility of the final choice goes down, but this is driven by items being higher prices. The yellow is the search cost. So this is actually saying people are saving some utility from incurring lower search costs in this market. We also see here, we're tracking the quantity in the booking revenue and the profits, and you see the profits going up, the revenue staying about the same. Okay, so to summarize the results, without price updates, we have a gain in consumer surplus. Once we let the sellers update their prices, we have a decrease in profits, an increase in profits, but a decrease in total surplus because the consumers either get priced out of the market or paying for higher priced goods. This is a little bit of a depressing result, so I'm gonna use the last minute talking about the next step, right? So personalization ends up harming consumers. But the idea here is that we can increase the price sensitivity of the recommendation system to try and discipline the seller side of the market to set more competitive prices. And so imagine a black box algorithm that's some function of price plus observables. Now it's a function of alpha times price plus observables, and we're just tuning for this alpha. So this is just simulated results, so this isn't the paper yet, but we might have something like this where we have 4 possible objective functions: total revenue, consumer surplus, hotel profits, total surplus, revenue. We're tracking the level of alpha, so as we go this way, we're more price sensitive. As we go this way, less price sensitive. And this would say that we could increase consumer surplus by making it more price sensitive. We could increase hotel profits by making it less price sensitive. You can imagine that, for example, the platform might want to do some weighted combination. Okay, so to conclude, what does this paper do? Set up a structural model based on clickstream data from Expedia that has a demand, a platform, and a supply side. From there, I'm going to train a set of increasingly personalized recommendation systems using data from a randomized experiment. Then I run a series of counterfactuals that both hold prices fixed and allow the sellers to update prices. So to conclude, what is the personalization paradox? So that as we increase the level of personalization, consumer welfare goes down. It improves welfare by steering consumers to products that better match their tastes, but it worsens welfare since sellers are able to take advantage of better matches.
Question.
I'm out of time, so I'll stick around after Gio gives his discussion. So I'll end there. Thank you so much.
Great. Thank you, everybody. Thank you, Kaye, and David for having me. It's always good to be in San Diego, particularly this time of the year. It's been raining pretty much every day in Chicago in the last week, so it was a good raid and a great opportunity to get back to this paper that Aaron actually sent me last year. So I took a look at it a while back. I was very happy to go back and kind of take a second look at the newer version. So let me give you my one slide summary of the paper. Very, very simple, just focusing on the essentials. This is a paper about personalized rankings and how they affect consumer surplus. And so there's 2 main forces at play. One is the one that maybe we would sort of first think of, which is that if I personalize rankings, if I know what my customers really like, I can serve them better products. And so this is gonna tend to improve consumer welfare, right? It's gonna reduce search costs. It's gonna make it more likely that people are gonna click on products that they like and eventually purchase them. So this is a good force for consumer surplus. What this paper really brings attention to is the second force that is maybe a little bit more subtle, maybe a little bit more sort of relevant in the long term, which is price adjustments. So now we have, particularly in 2-sided platforms, so in platforms that match sellers and buyers, we now have another side of the market, which is the seller market. And they might now, because of personalization, they might face consumers that are better matched and therefore have higher willingness to pay, right? They are more willing to pay for their product, for the seller's products, And therefore, as a result, sellers might have an incentive, and generally will have an incentive to raise prices in response. And so this is obviously going to be something that could be hurtful for consumers. And so there's two trade-offs, there's two forces that should be traded off against each other. And in order to quantify the sort of relative impact of these two forces, without really being able to run an experiment and sort of shut off personalization, we need a model to sort of help us out. And so in particular, the margins that the model needs to take care of are, well, number one, consumer search, right? So we cannot have a model that assumes full information, because otherwise there will be no room for personalization if consumers know everything, sort of when, that everything about every product, there's no room for personalized recommendations to have an impact on their choices. So first we need some sort of search friction, some sort of inattention on the part of consumers. On the seller side, we want to indigenize pricing, and so be able to model how sellers would adjust their pricing as a result of the different personalization levels. And finally, we need to sort of think about how the platform would actually roll out personalization, what their baseline algorithm is, and how that would change as a result of additional data being brought in. So impressively, the paper does all three. So there's all of these three margins are endogenized, and so I think that's sort of something that should be recognized as very good. So good job, Aaron, on taking on something that's very ambitious. The punchline applied to historical Expedia data is that the negative force, so the force where prices increase and as a result could harm consumer surplus, is actually the one that dominates. So this offsets the beneficial impact of personalization on in terms of leading consumers to better choices. And so what this implies is that if we ignore the second channel, the pricing channel, we would get not only the magnitude of the welfare change wrong, but also the sign. So we would just completely kind of get the conclusion wrong in terms of even direction. This is my one slide summary. This is a very ambitious paper. There are a few things that Aaron is still working on, but sort of I think they're going in the right direction. So this is on its way to be, I think, a very well executed and very, very solid paper. I'm not going to suggest a whole lot of changes to the paper because I think it does already a lot. I'll have maybe one suggestion that I'll show you in maybe 2 slides. What I will do with the rest of my time, I'm going to relate this to 3 main areas that I think this paper speaks to, that are quite kind of distinct. So again, nice feature of the paper is that it speaks to quite different litteratures. The first one is search. And so when I first, this was last year, when Aaron first sent me the paper, the first thing sort of I thought about was this literature, theory literature on the relationship between price transparency and price competition, right? And so what the literature tells us is that whether or not sort of search costs and search frictions are a good or a bad thing for prices, for consumer, and therefore for consumer welfare, really depends on the visibility of prices, right? So if we have that prices are not known exactly by consumers, so if consumers need to pay a cost to learn prices, then intuitively search costs are anti-competitive, right? So another way of saying this is that if I reduce search frictions, I'm gonna make sort of prices more visible for consumers, and this is gonna tend to increase price competition and bring prices down. So we have this kind of relationship between reduction in search cost and lower prices, which is what maybe sort of we would expect. Maybe less intuitive result that is a nice paper by Choi et al. That highlights this is that if instead prices are visible to consumers, so if price is something that I immediately see on the results page, and that determines whether or not I continue to search and click on the product and learn more about it, then actually we can have the opposite result. So a reduction in search costs, so less search frictions, can actually be bad for consumers, can induce more price competition or less price competition. What is the intuition here is that if price is known pre-search, there's an incentive for sellers to use price to lure consumers to their products, induce them to click on the products, learn more about the product, and perhaps buy it. As I reduce search frictions, I'm basically reducing this incentive to lure customers with a lower price, and this can lead to higher prices in the long run. Why am I bringing this up? Because when I first, thought about personalization, to me, in my mind, I thought, okay, personalization is a reduction in search costs, right? It's something that makes it easier for customers to find what they like. And so immediately I was trying to map this paper into this existing literature. And here, importantly, Aaron maybe didn't have a lot of time to talk about this, the price is actually not fully known, right? So there's a base price that is shown to consumers, but then you actually need to click on the products to learn more about the actual price. There's add-ons, there's obfuscation. And so we're really actually, from a sort of perspective, if I want to map this to the theory, we're really in the first bullet point, right? Where price is not fully known pre-search. And so if I just took this literature, theory literature, I would expect a pro-competitive effect of search strictures, right? Where if I remove search strictures or I personalize the results, I would expect sort of lower prices. But this is not what we find, right? In this case, we find top prices that are actually higher and that harm consumers. So how do we reconcile these two? And this was actually a helpful conversation that I had with Aaron over email, and so I want to share with you some of the things that were helpful for me to clarify this distinction. What is the relationship between maybe a standard kind of reduction in search frictions in standard search models and personalization? How does personalization sort of differ from just what we would expect, what we would label as a reduction in search frictions? So first of all, a reduction in search frictions, imagine something like going from, pre-internet to internet commerce is something that generally sort of applies across the board. So all products have now lower search costs. Personalization, yes, reduces search costs for some products, but it's very uneven, right? The products that are promoted to the top are going to be, have a much lower search cost. So the best matches are generally going to have much lower search cost. But the products that are not good matches are going to be buried at the bottom of the ranking and therefore maybe even have higher search costs. So there's a key distinction here between a completely sort of even reduction in search costs, which is how in the search literature we would generally think about removing search frictions, and something that is a lot more uneven in personalization. And this is really the main force that drives the mechanism here, right? So if because of this, because the best matches are promoted, sellers now face higher willingness to pay customers and therefore are willing to can afford to price hike. Generally in search literature, we also don't think about search costs as being affected by prices. We tend to think of them as something that is kind of a primitive of the problem. But here, rankings are mechanically affected by prices, right? Because if I price lower, all else equal, I'm gonna be favored in the rankings. So there's also this additional channel, which actually goes in the opposite direction. This would give an incentive for sellers to reduce their prices as a result. And then also just kind of highlighting that the paper takes care of a lot of different things here. Again, normally we might just model marginal cost as constant, but here actually Aaron also takes care of the capacity constraints, which are obviously sort of relevant in the hotel industry. And this also means that, as I face more demand, let's say with personalization, I have more people that are interested in my products. This is gonna tend to increase my occupancy rate, and therefore it's gonna increase the marginal cost, which is the opportunity cost of getting an extra room away, right? So if I'm almost at capacity, I really wanna think carefully about giving my last room to someone, because if I do so, I might not be able to book it to someone else tomorrow. All right, the one thing I wanted to highlight, I'm gonna keep it very short. This is also where there's one bit of self-reference, so forgive me for this, but I do think it's relevant. The search model in the search model, customers learn about their match value or part of their match value. And also they can learn about something in terms of vertical quality for the products, but only to the extent that those are captured by the data. So in particular, the exact location of the hotel. I do think in practice, this is probably not what happens in the data, because there's a lot of information on the product page, images, reviews that customers can use to really understand the quality of the hotel. And I think modeling that can be interesting, because in this paper we find that really what determines whether a ranking is good or bad for consumers is the surprise that the hotel or the product delivers to customers on average relative to their reservation value, relative to sort of the expectations that they have. And so really modeling this vertical dimensional surprise, does this hotel on average give a good surprise or a bad surprise to customers, can really sort of inform the welfare impacts of ranking. All right, I don't have a lot more time, so I just want to highlight, let me switch to the second literature that this speaks to. So far I've focused on search. personalization. So there's a growing literature that talks about personalization. My colleagues JD and Sanjoga worked on price personalization. Malika, who's sitting over there, is in her job market paper is actually on rankings personalization as well. And I think it's great to see different approaches to similar problems. I think these are all very complementary. There's a lot of differences. Most of these papers in the literature use experiments, and so they are able to really partnering with companies, maybe shut down personalization and immediately measure sort of the impact of doing that on a number of metrics. Where this paper, I think, really shines and what it adds to the literature is this idea of modeling long-term impacts, right? So how do buyers and sellers react to personalization? So how do sellers change their pricing? How do buyers change their expectations about rankings and how they think about what a ranking means for the underlying quality of the product? And so the way I think about this is it's really via sort of a strong modeling effort, being able to say something about the long-term equilibrium in this market. Which brings me to my last point about endogenous beliefs. So there is also kind of a budding literature, Olivia, right there. I think Olivia, Jessica, and PhD student from Kaye, perhaps, have a paper that really gets at the point of, do consumers adjust their beliefs if you change the underlying rankings? So how do I interpret a product that is ranked number one? Does that vary with the underlying way in which the products are ranked by the platform? And they find that sort of, especially in the long run, this may be important. Their customers sort of, if they're exposed over time to a different type of ranking, eventually they kind of learn what the underlying mechanism and the underlying algorithm is. And so this paper does account for this, which again speaks to the fact that it can focus on long-term effects. And here I think maybe clarifying a little bit, so I think Aaron has gone back and forth in terms of how to model this. What is the timing of adjustment? Do prices adjust after or before beliefs, consumer beliefs? So clarifying, which assumptions are needed to make this work. I think existence in case of equilibrium should be actually, by backward induction, you should be able to just kind of very easily show it, but just clarifying it for the reader would be helpful. So I am just on time, so I'm going to wrap it up here, and thank you very much.
Thank you so much for the great discussion. I don't really have a response because I pretty much agree with everything it said. I think for adding the fixed effects, that's something that's like really interesting and I've thought about. There's just some like engineering holdups, so I'd be happy to talk to you more about how to work in more parameters to the model, because I think that's something that's important. One of the things you also mentioned in a conversation is like, unfortunately I don't have the photos, but I think like if I were to apply this model somewhere else, using information from the photos would be really helpful, as well as like capturing kind of what's known ahead of search versus what's learned from search in terms of quality. So I'll stick around here if people have questions after. I know we ran out of time, so thank you so much.
Okay, we've got 30 minutes, and after that, we'll hear from Ashvin on fake reviews and from Yost on the platform's literature. Oh, I believe there's fresh coffee downstairs on the second floor.